Hi, hello everyone. This is Dr. Manuri Brahmayya, Assistant Professor, Department of Chemistry, VNR VJIT. Today I am going to talk about synthesis of bakelite. So the preparation of the bakelite apparatus required is 250 ml beaker, 100 ml beaker, 5 ml measuring jar, glass rod, droppers and filter paper. Chemicals required: 5 ml glacial acetic acid, 2.5 ml of 40% of formaldehyde and 2 grams of phenol and 1 to 2 ml of concentrated HCl. So these are the chemicals required. Initially we will take this 5 ml glacial acetic acid into the 250 ml beaker, and then we will add 2.5 ml of 40% aqueous formaldehyde solution. So we can see here, and then we have to stir it properly. Then we can add 2 grams of phenol, and then slowly we can add the 1 to 2 ml of concentrated HCl through the walls of 250 ml beaker. Then stirring vigorously, then we will get our final product bakelite. Let's get into the lab. Take 250 ml beaker, then take 5 ml glacial acetic acid into the measuring jar, 5 ml measuring jar. Exactly we can take in 5 ml glacial acetic acid into the beaker. Then you can take 40% aqueous formaldehyde solution, 2.5 ml into the beaker. It's 2.5 ml formaldehyde solution. With the glass rod, with the help of the glass rod, mix properly this solution until you get a uniform homogeneous solution. Like, since the glacial acetic acid is a weak acid, the reaction is also happened in the in the presence of the acid. So then we can add phenol, 2 grams of phenol. It is almost 1.87 ml. So nearly 2 ml we will take that phenol into the measuring jar. Then we can pour into the beaker, which is already having a formaldehyde solution as well as a glacial acetic acid solution. In that beaker, once we are added the phenol properly with carefully, then you can stir this mixture with the glass rod to make a uniform solution. So we are making it is a uniform solution. Then add concentrated HCl 1 to 2 ml. With the help of the dropper, you can add the concentrated HCl into the beaker through the walls of the beaker, or either with the help of the glass rod, putting the concentrated HCl solution on the glass rod or walls of the beaker. Since the reaction is exothermic reaction, we should be very careful while we are adding the HCl solution. We have to stir properly. Stirring properly the mixture, the reaction mixture is now is going to make a Novolac polymer, a linear polymer. Initially it will become Novolac, a linear product, and then finally it will become like a bakelite by adding the curing agent hexamine. Then finally you will get your bakelite polymer. So after Novolac polymer, linear polymer, it will become a Bakelite. So then the bakelite will be, this product will be filtered off to remove the acid solutions and then make it dry properly. This is the Novolac product with some malleability. So this is the way how to prepare our bakelite in our laboratory. The pink color product which is formed, you can we can see this one. So finally we can find a yield of that product. You can see the in the video, weight of dried Novolac obtained by total weight of the reactants used into 100. This is the percentage of the yield of the final product. In the conclusion, today we have prepared Novolac, the linear phenol formaldehyde resin. In industrial practice, Novolac is converted into Bakelite by adding a excess formaldehyde solution or hexamethylene tetraamine, which is called hexamine, as a curing agent, followed by heating under pressure. The curing step forms additional methylene bridges, producing a rigid 3D thermosetting polymer called Bakelite. Since curing requires high temperatures processing equipment, this laboratory experiment concludes with the preparation of the Novolac, the precursor to Bakelite. This product is always used in electrical switches, plug tops, switchboards, insulating components, fuse holders and lamp holders. Thank you.